lesson 1.5 for accelerated pre-calc, combinations of functions. So let's get into the lesson. Alright, so the sum, difference, product, and quotient of functions. This is pretty straightforward. So the main idea you need to understand is if you have two functions, okay, and if their domains are overlapping, then basically you're allowed to add the functions, subtract them, multiply them, or divide them. Okay, just be careful when we're dividing. Remember you don't want 0 in the denominator, so you're gonna have to restrict the domain for the denominator. Okay, so let's take a look at the first example, and it's pretty straightforward. So let's say we have two functions, f of x and g of x. If you want to add them, right, let's say this is f of x right here. Let's say this is g of x. Basically just combine like terms, right? There's already a plus sign, so we just combine like terms. So x squared is not like terms with anything, 2x is not like terms with anything, but -3 and -1 gives you -4. So this would be the sum. The same two functions, let's say we're subtracting them. Just remember, when you're subtracting, remember to always put the parentheses, so that way you remember to distribute. Okay, so that'll give you -x squared plus 1. And then afterwards, combine like terms. Okay, so we have -x squared, 2x, and then -3 and +1. That's going to give you -2. Alright, so real straightforward. We've done this before in Integrated 2 Enhanced last year. Over here, if you're multiplying the functions, right, basically all you need to do here is FOIL or use the box. So all you're doing is you're distributing twice and then combining like terms. Okay, and nothing's like terms here, so that's why that would be your answer. And then down here, if we take f of x, which is 2x minus 3, and g of x, which is x squared minus 1, typically what you would want to do is you would factor the denominator here. So x plus 1, x minus 1 here. And you notice in the numerator, after you factor this out, you want to look for like factors that would divide out. This problem doesn't have any, but if we had an x plus 1 on the bottom, and let's say and also an x plus 1 on top, we would be able to divide those out. And that's what you would look to do. Alright, but this problem, nothing divides out. So basically this is your answer right here. But you have to make sure that you restrict the domain. Right, so we don't want 0 in the bottom. So when's that going to happen? Right here, x cannot equal -1. Over here, x cannot equal 1, because that's going to make 0 in the denominator. Okay, so the domain in the denominator is basically anything for x except for -1 and 1. Okay. So let's take a look at the first example now. Given f of x is 2x plus 1 and g of x is x squared plus 2x minus 1, they want us to add, just add the functions. And then evaluate it, the sum when x equals 2. So first you're going to add the functions, right? So you're basically going to take, here's f of x plus g of x. Alright, so this means the same thing as f of x plus g of x. So just understand when they give you this notation here, it means the same thing as this. So we're going to add the functions. So f of x is 2x plus 1. And you can put in parentheses if you like, plus g of x, which is x squared plus 2x minus 1. And then we're just going to combine like terms because we're just adding them. So we get x squared plus 4x. Right, and then the +1 and -1 cancel each other out. And then we need to evaluate this for x equals 2. Right, so we're going to evaluate this for x equals 2. So what you're going to do is you're just going to plug in 2 for the x's, squared plus 4 times 2. So that's going to give you 4 plus 8, which is 12. Alright, so that's all that is right there. Right, pretty straightforward, nothing complicated. Let's talk about finding the difference of two functions. Let me crop this real quick. to get this information. Alright, so we need to subtract the two functions. Remember, this notation right here means the same thing as f of x minus g of x. Right, so f of x is 2x minus 1, sorry, 2x plus 1. And you could put it in parentheses if you like. Minus, and then g of x is x squared plus 2x minus 1. And as I've told you guys before, I highly recommend anytime you're subtracting something, always put that parentheses so you're going to remember to distribute the negative. So when you're subtracting, it is very important to put this parentheses so that all of you remember to distribute that negative. Okay, very common mistake. So we're going to distribute the negative now. Negative x squared minus 2x plus 1. And then we're just going to bring this down. 2x plus 1. Let's combine the like terms. So we end up with negative x squared. The 2x and the negative 2x cancel out. And we get plus 2. Alright? And then now we're going to evaluate it for when x equals 2. Alright? So we're going to find out when x is going to equal. When x is 2, what this will be. So you be real careful when you plug this in. This should be negative, and then in parentheses we have 2 squared, and then we have plus 2. Right? So that way when you square the 2 here, you get 4, and then you remember that negative attaches to this 4 here. Okay? Plus 2. So our answer is going to be negative 2. Okay? Alright, so let's take a look at example 3 here. So, product. We've got to multiply. Let me just crop this real quick. So we're going to multiply these functions. So f times g, right? This just means f of x times g of x. So we're multiplying these. That's all we're doing. So f of x right here is x squared times g of x, which is x minus 3. So we're just distributing x to the third minus 3x squared. And then we're evaluating this for when x is equal to 4. So 4 to the third power minus 3 times 4 squared. So 4 to the third is 64. Over here, make sure you do the exponent first. Square that, you get 16. 16 times negative 3, negative 48. And then we're going to subtract that, so we're going to end up with 16. Okay? Alright, so let's take a look at this division one. Let me crop this real quick. Okay. So first we need to find f divided by g of x, and then we're going to find g divided f of x, right, for the functions given right here. Alright, so first of all, I'm going to focus on f divided by g of x. So this notation means the same thing as f of x divided by g of x, right? And we know f of x here is given to us. That's square root x. And g of x is square root 4 minus x squared. Okay? And then we need to find the domains of f divided by g and g divided by f. So I'm going to focus on this problem first right here. Alright. Well, is there anything to do in this problem? Okay, there's nothing to simplify. So basically that's all you would do. You would look to simplify if you can, but you can't. So there's nothing else to do for this problem in terms of simplifying. Okay? So now let's find the domain then. So we need to find the domain of f divided by g. Well, let's look at the domain for the top. What's the domain for this top function right here? Well, for this function right here, remember, we don't want any negatives inside the radical. So basically right here, this is going to be x is greater than or equal to 0. Alright, and how we would express that in the interval notation, that's going to be 0 to infinity. Right? Let's take a look at the bottom. What's going to be the domain for the bottom? Alright, and we've done a problem like this before, so I'm just going to jump to the answer. So we know that the domain for the bottom here is basically going to be all the values between -2 and 2. All right, so all the values between -2 and 2. All right, so the domain, all right, the domain for this problem, all right, remember this was just the domain for the top. This is the domain for the bottom. So the domain for the problem is going to be where these two domains overlap, where they overlap each other. Okay, and I mean, let me draw a number line just to make it a little bit more visual for you guys. So the domain for the top here is basically, so here's the x-axis. Okay, here's 0. So we're going to include 0, and it's going to go to infinity. Okay. For the bottom here, -2 to 2 is our domain, right? Is our domain right here for the bottom here. So where it overlaps, where these two domains overlap, is the domain for the whole problem, for this whole problem. So the domain for the whole problem would be, well, where does it overlap, right? It overlaps from 0 going to 2. All right, so the domain for the whole problem would be 0 to 2. Now here's where you need to be careful. Do we want to count 2 for our domain? Okay, so if you plug in 2 here into the bottom, it's going to make 0 in the denominator, right? It'll make 0 in the denominator. So we're not going to want to count 2. Right? So the domain for this problem is going to be 0 inclusive, to 2, but we don't count 2. Okay, so that's f divided by g. So I'm going to do the same problem now. So g divided by f. G of x divided by f of x. So we have the square root of 4 minus x squared over the square root of x. And it's pretty much the same idea. Okay, you would look to simplify first if you can. We can't simplify anything. All right, so then we're going to find the domain. Well, we know the domain for these two already, right? Basically, this right here is going to be, the domain is going to be -2, 2. The domain for this is going to be x is greater than or equal to 0. All right. And then, so the domain for the whole problem is where the two domains are going to overlap. All right. So it basically is going to be the same thing as this right here, because the overlapping is not going to change. So then we end up with 0 and 2 still. Now be careful where you want to include the point. Right. Now, do we want to plug a 0 into right here? Right, because the square root of 0 is going to give you 0. Okay, so we don't want to include the 0 this time. All right, we plug in a 2 right here, that's fine. The square root of 2 is going to just give you some value. I believe it's 1.41. All right, that's fine. But we don't want to plug 0 into here because that's going to make 0 in the denominator. All right, so we can include the 2, that's fine. Okay, so this would be the domain for the whole problem for g of x divided by f of x. All right, so the main idea, when you have a division problem, find the domain of the top, all right, the numerator, find the domain of the bottom, whatever it is, all right, and think about where the two domains would overlap. Where they overlap is the domain for the whole problem, okay? And when it comes to thinking about what points you want to include or not, think about what, it goes back to the same idea. We don't want 0 in the denominator, right? We can't divide by 0 in the denominator, and we don't want negatives in even index radicals. Okay? Alright, so let's take a look at this problem right here. Okay, so we have a composition of functions here. How do we know it's a composition of functions? Well, we have this little open circle right here, right? And remember this notation right here, f, this is read f composed with g, right, of x. This is the same thing as f, right, g of x like this. These two notations are the same thing. Okay, now we know what the f function is. It's square root x. We know the g function is x minus 1, and we're given some domains to work with already, so we've got to abide by these domains. Alright, so now remember, when you are working with the composition of functions, always start with the inside function. So we need to figure out what this is. Alright, this one's pretty easy because there's really no work to do. G of x equals x minus 1 right here. So all you're doing is you're just taking this and you're just plugging it in right here. Okay, so we're going to end up with x minus 1 here. Okay, and then we need to work with the outside function. The outside function is the f function, right? So the f function right here, we know f of x is equal to square root x, right? Well, we need to find out what f of x minus 1 is. Well, that just means wherever there's an x, plug in x minus 1. Square root of x minus 1. Okay? And then this is your answer right here. Alright, so f composed with g of x, this is your answer right here. Okay, so this is our answer right now. Now let's find the domain. To find the domain, right, you always start with the inside function. Right, so to find the domain here, alright, we start with the inside function. Oh, so g of x. What's the domain for g of x? X is greater than or equal to 1. So let me just make a number line so it's kind of easy to see. Here's 1. We're going to count it. Alright, and then we're going to infinity. Right? What's the domain for f of x? The outside function, right? We'll always start with the inside function and find the domain of the inside function. In this case, it's given to us. Now, the outside function, f of x, the domain is 0, right, to infinity. Now, the domain of the problem is where these two overlap. Okay, the domain has to initially exist in G, right? So whatever the domain is in G, that's also in F. So meaning where they overlap, okay, where the domain in G overlaps with F. Well, in that case, the domain is going to be from 1 to infinity. So this would be the domain of the whole problem, F composed with G. All right. So now we need to evaluate basically f composed with g of 2 and f composed with g of 0. So let's find f composed g of 2. Now we know what this is, right? We just found the answer to this already. It's this guy right here. Okay, square root of x minus 1. So all you're really doing is you're plugging in 2 into right here. So 2 minus 1. So we know we're just going to get the square root of 1, which equals 1. Right? Okay, and then for the other one, if we're trying to find f composed with g of 0, right? Now be careful, don't just start working this out without thinking. Is 0 in our domain? Right? Remember, this is our domain right here. 0 is not in our domain, so this is not going to be defined. Okay, so you can't find this. Okay, so this is not defined in our function. Okay. Alright, let's take a look at the next example here. Crop this. Alright, so we're doing pretty much the same thing. We're given two functions, f of x and g of x. We need to find f composed with g, and then also g composed with f. So I'll do this one first. Okay, so I'll focus with f composed. So f composed with g of x, and then we're also going to have to evaluate after we find out what this is. Okay, so remember, this is the same thing as this notation right here. So we're starting with the g function, or the one right next to the x variable. So remember, we're starting with this right here. We're starting with the g function. What's the g function? The g function is 4 minus x squared. So let's plug that in. 4 minus x squared. Now in the f function, right, in the f function, we're going to plug in 4 minus x squared, alright, for f. So f of x is equal to x plus 2 So since we are finding f of 4 minus x squared, wherever there's an x, we just replace it with this. Okay. So we're going to end up with 4 minus x squared plus 2. And then just simplify that. So f of 4 minus x squared is equal to basically negative x squared plus 6. Okay? Now let's think about our domain for the whole problem. Well, start with the inside function. Our inside function was g of x, right? So g of x here, what's the domain for this? Basically, it's all real numbers, right? It's basically negative infinity to infinity. And then go to the f function. What's the domain of this over here? Well, the domain of this is also negative infinity to infinity. So since the domains overlap at negative infinity to infinity, the domain of the whole problem is going to be negative infinity to infinity, meaning we can plug in whatever we want. Sorry, that should not be inclusive. Alright, so since we can plug in whatever x values we want, I'll just evaluate, I'll find out when x is equal to 0 and when x is equal to 1. Right? So we need to evaluate this right here. So negative 0 squared plus 6, well, that's just going to equal 6. And then when I plug in the 1 squared plus 6, 1 squared is 1, attached to the negative, so plus 6, we're going to get what? 5. And you would just do the same thing for the other values. Okay. So that was for f composed with g. Now let's do g composed with f. Alright, so this notation means, hey, the g function is the outside function now. Alright, f of x is the inside function. So let's find out what f of x is. We know what f of x is. F of x is x plus 2. Now we work with the outside function. The outside function is g. And then g of x, right, is 4 minus x squared. So g of x, we know, is 4 minus x squared. So since we're finding g of x plus 2, wherever there's an x, we just replace it with x plus 2, and then we square it. Now be real careful how you work this out. You've got to square this first, so that's x squared plus 4x plus 4. Keep that in parentheses, and then distribute the negative after. Okay? So you get 4 minus x squared minus 4x minus 4. And then combine like terms, we're going to end up with negative x squared minus 4x. And then the 4's basically cancel each other out. So this will be our answer right here. Right, negative x squared minus 4x. And then if we need to evaluate, right, I mean, once you find the domain is negative infinity to infinity for both of these functions, right? So the domain for g composed with f is also going to be negative infinity to infinity, right? Because it overlaps for, f of x, right, and then g of x. So we can plug in all these values. So if I need to find x is equal to 0 and 1 again, if I plug in 0 here, 0, I'm just going to get 0. And then if I plug in 1, right, negative 1 squared minus 4 times 1, I'm going to end up with negative 1 minus 4, which is negative 5. Alright? One thing you want to keep in mind is you notice f composed with g, alright, was not equal to g composed with f. Right? We got different values here. So be careful. So don't think that f composed with g and g composed with f, alright, are going to equal each other. Right? They can equal each other, but don't think they have to equal each other. Alright? So let's take a look at the next example. Finding the domain of a composite function. Alright, so we've kind of alluded to this already. So if you're finding the domain of a compositional function, right? So find the domain of f composed with g. Right, so we're finding the domain of f composed with g. So we need to find the domain of g of x first. Alright, so what's the domain of g of x? Alright, So g of x, the domain here, and we've done a problem like this before, it's going to be negative 3, 3. The values are between negative 3 and 3, inclusive of negative 3 and 3. Alright, so that's the domain for g of x. Now, the domain for f of x right here, okay, so the domain for f of x right here is basically going to be negative infinity to infinity. We can plug in whatever we want. Right? There's a polynomial. We're never going to divide by 0. There's no radicals. Right? So for g of x here, let me just make a number line. Is basically negative 3 to 3. Right? This is the domain, right, for g of x, the inside function. The outside function, f of x, the domain is basically the whole number line. Okay, negative infinity to infinity, right? The whole number line. Right. Well, the domain for this composition here, f composed with g, is going to be the values of g that are also in f. Okay, well, the values of g here that are also in f, well, that's going to be negative 3, 3, inclusive. Okay, and always be careful. I mean, we don't have division here, so we're okay, right? Alright, so you always want to look out for division when you're trying to think which points you should include or not include, because you don't want to divide by 0. But since there's no division here, where it's impossible for us to divide by 0. Okay, so let's take a look at the next example. Alright, so let's take a look at this example right here. Okay, so we need to find f composed with g, and then g composed with f. So f composed with g. What's the g function? The g function is 1/2 x minus 3. Right? That's the g function right here that's given to us. Now we need to take this, plug it into the f function. The f function is 2x plus 3. So we have 2, right? And then instead of x, I replace it with this. 1/2 x minus 3 plus 3. Okay, so if you simplify this right here, basically you're going to end up with 1/2 x minus 3 over 2 times 2. And when you distribute the 2 here, basically you end up with x minus 3, and then you have the plus 3 out here. So you end up with x. Okay, and then over here, let's find g, right, composed with f. Well, f of x we know is 2x plus 3. Now, if we take this, we plug it into the g function, right? So g of 2x plus 3. Here's the g function. We have 1/2 parentheses x minus 3. So instead of x here, we replace it with this. 2x plus 3. And then we have minus 3. Well, the 3's cancel. We end up with 1/2 times 2x, which is going to just give you x. So this is a special case where f composed with g and g composed with f are equal to each other, because we ended up with the same answer, which is x. Okay, and we'll talk more about this in a future lesson as to why this is the case. Right, so just keep in mind it is possible for f composed g and g composed f to be equal, but they do not have to be. Okay. Next thing, basically writing a composition of functions. All right. Write the function as a composition of two functions. Okay, and it's pretty simple. So basically right here, we need to write the function h of x is equal to 3x minus 5 to the third power as a composition of two functions. So first of all, I can make, let's say, f of x if I want to. I can make f of x equal to x to the third. If I make g of x equal to 3x minus 5, right? So basically, to get this right here, I would have to take this function, I would have to take this g of x and plug it into here, right? So it's a way to express that. Well, we have f g of x, right here. If you take the g function, you plug it into here, you would get this, right? So h of x is equivalent to f composed with g of x, right? If you take the g function, you plug it into our f function here, you would end up with h of x, and that's all that is right there, real simple. All right, so that's how you could take a function, all right, and write it as a composition of two functions. Okay. Let's do the same thing right here. So another practice. So here's h of x right here. All right. So let's say I make f of x equal to 1 over x squared. Well, if I make g of x equal to x minus 2, if I say, hey, let's take f composed with g of x, right? If you were going to work this out, you would take the g function, which is x minus 2, you would plug it in here, and you would end up with the h function, right? So the h of x is equal to f composed with g of x. Okay, so that's how you would write a function as a composition of two functions.